Okay, sorry about the interruption. We'll throw in another video here that finishes the bottom of page 2 for 9.2. And I have the phone on mute, so hopefully we won't have any more interruptions here. So let's try number 64. Same idea. We're multiplying and then trying to separate out the perfect square so that we can write it in the simplified form as possible. Now, what's different here than the one we just did? Well, we've got more variables happening on the inside, and we also have different numbers here, but it doesn't look too much different on the surface, but let's see what happens when we multiply. We can make this one big radical, and we're multiplying 50 times 4, and we're also multiplying x to the 9th times x to the 4th. So I'm just writing out every single step so that your notes really speak to you. You'll be able to do a lot of these steps in your head, I'm sure, once you get comfortable with these problems. But until you're comfortable, writing out a lot of steps will help you push this into long-term memory, which is really the goal when you're trying to do well on exams. So 50 times 4 is going to give you 200, and x to the 9th times x to the 4th, you add those exponents, you get x to the 13th. So what's different now is starting to show up, because before we had nice perfect squares. But now, with 200x to the 13th underneath, we're dealing with more of a situation like we were at the top of this page of notes, where we're going to deal with the variables and numbers separately still, but we're going to look to split them out into perfect squares. So x to the 13th, let's bring that one up here. Radical x to the 13th, by definition, that's x times itself 13 times under here, under that radical. So you can imagine you're looking for how many pairs of x can we get, how many x squareds can we get out of that, because each one of those x squareds will turn out into an x. And essentially what you're doing is you're going to take that 13, that exponent, divide by your index. We're looking for how many pairs we can get, because perfect squares would be a pair of x's, x times x. And 13 divided by 2 is going to give you 6, because it goes in 12, with a remainder of 1. And then 6 becomes your outside exponent, meaning outside the radical, and your 1 is then your inside exponent. There's going to be 1x left on the inside of the radical. So that one simplifies to x to the 6th square root of just x, or x to the 1st. We just write it as x. Now let's look at 200. We want to know what times what will give us 200, where one of those pieces is a perfect square. And in fact, 200 breaks down to 100 times 2, and we know the square root of 100, so we can separate those two radicals out here, and we know the square root of 100 is 10, and then 2 is just left on the inside. So now our final answer then combines both of those pieces, where we take our outside pieces, 10x to the 6th, and then under the radical you have 2 and x, or 2 times x. So that is our most simplified version, 10x to the 6th radical 2x. And I'm just going to be extra clear here. The 6 is not part of the radical. It is the exponent belonging to the x outside. The radical is still a root 2 here. Okay, so there's still a 2 underneath, or understood to be there. So it's still a square root, because that's where we started. The root's not going to change. Once you have a root that you're working with, that part doesn't change. Okay, so take a moment and talk through these examples for yourself. Make sure your notes are complete, and then if that helps you, some people just can watch the examples and not really have to take notes, but some people need to take notes so that your hands go through that motion and you're ready to then do your own work when you get to the problem set. So really find your rhythm here, and if you're unsure, I'd be happy to have that conversation with you to see if we can kind of determine what's your best learning style. But anyway, get the notes down that you need that help this make sense to you. Note any questions, bring those to class, and then pause the video and try number 62, because when come back, we'll have the answer to that one. Okay, so the answer to number 62 would be 2x on the outside, square root 5x on the inside. That's the simplified version of that one. And finally, finishing up this page, on page 561, there's a helpful reminder here of simplifying your square roots with variables to even powers, and they've got x to the 2n just becomes n. In other words, there's that division by 2. That 2n gets divided by the 2, just cuts it in half. Now that doesn't mean that you can't raise odd powers, because that's what we did. And we just went one step further and said, hey, this works for all of them, so why memorize two different rules? Just divide the exponent by the index, and your answer is going to be what's on the outside. Your remainder is what's going to stay on the inside. It remains inside. Okay, see you on page 3.